Good morning, everyone, and welcome to the Tejano Virtual Events Happy Math Hour, your weekly interactive math reviews for Math 1314 and Math 1324, presented by Yvette Chuca, Ruben Carrizales, and Albert Isasi. This session will be recorded so that you may come back to it at a later time, and also for those who may have missed today's presentation, may be able to watch it at a more convenient time. Okay, for those of you attending the 1324 room, there will be a link posted on the chat so that you can click on it and follow that. So thank you now. So at this time, please mute your mics for the best sound experience. We don't want any feedback interfering with today's important lesson. Without further ado, here is Yvette Chuca and Ruben Carrizales. Thank you.
Hello, everyone. Welcome to Friday Happy Math Hour. Again, if you are in 1324, they will put a link so that you can go to another room. For 1314, you're just going to stay here. So today we're going to look at examples for sections 1.5 through actually 1.5, 1.7, and 1.8, I believe. And so these are sections that if you're in a 10-week course, then you're probably in these sections. If you're in a 5-week course, then you're getting ready to probably take an exam. So first, I wanted to just give you a quick example on evaluating functions graphically. These are coming from section 1.5. And so if we look at this graph, it says use the graph to find the domain and range, and then use the graph to find the indicated values. So in the last session, we talked about domain and range. And we said that the domain is basically all the x values that you are using to create this graph. So for example, if I look at x equals -5, and if I go up and if I go down, I'm not going to touch the graph. So -5 is not part of that domain. Okay. And so let's go ahead and find the domain. So the values that are being used start at this point here. And if we go up, we see a circle, but it's not shaded. So this circle, we call it an open circle. And this circle represents that the number at x equals -2 is not part of the domain. And the reason we use this circle is because there are lots of numbers that are close to it. And so we want to include those numbers in there. If you see a shaded, a filled circle, then that means that the point is part of the domain. Okay, so let's look at the domain a little bit closer. So since I have an open circle, then if we write it in interval notation, we use a parentheses to represent that open circle. And again, the value for x is -2. And then all of these values in here are being used. And then we get to the number 2. And so number 2 has a closed circle. And we use a bracket to represent a closed circle. So when you see a parentheses, that means that the number is not included. And if you see a bracket, that means that the number is included. Now for the range, we're looking at the y values. So what y values are being used to create this graph. And so if we look at, and you always want to write down your smallest value first. So we start with the negative numbers. And the first negative number that is being used to create this graph is -4. So we're going to use a bracket, -4. And we keep going up. All these y values are being used because if you pick any of these y values and you go to the left or you go to the right, you're going to end up on the graph. And so all the way to 5. Now here for 5, it's being used on the right side, but not on the left side. So as long as it's being used on one side, then we use a bracket. So that would be your range. Okay. Then it says to evaluate the graph for these indicated values. So inside the parentheses, that numbers represents the variable x. So when x is -1, they want to know what is the output, what is the y value. So for -1, which is right here where my arrow is, if I go down, then I can see that the y value for that is going to be a -4. So my answer for that would be -4. If x is 0, if I go down to the graph, then that value is -3. So my answer would be -3. And then for x equals 1, if I go down, I end up at -4 again. And then for f of 2, if I go up, then we're going to end up at 5. Okay. And so that's how we would evaluate the graph for those indicated values. So we'll try another one. The domain. So here we have an arrow. So that means that all of these negative values are being used, even though we can't see them, but the arrow represents that it goes on forever. And so we are going to write for the domain -infinity. And then we keep going, we get to 1. And then for 1, we're using 1 since it has a shaded circle, right? And then it jumps up to, then we continue to use all of these numbers again. So your domain is going to go from -infinity to +infinity. Now, whenever you're working with -infinity and +infinity, that means that we use parentheses because we don't know exactly what that number is. And so for -infinity, +infinity, you want to use parentheses. Now for the range, your smallest value that we see here is -2, but we have an open circle. So to represent that we're not including -2, we use a parentheses. And then all the y values here are being used. So we go all the way to infinity. Okay. Now to evaluate f of 2, so f of 2 is here, so that's going to be 0 for y. And then f of 1, well, when I'm at 1, if I go down here, it's an open circle, so that's not going to be included in our answer. So our 1 value is going to be 0 again. And then f of 3, we go up, and it looks like it's 2. And then f of -1 is going to be 2 as well. Okay. So now the other thing that you're going to be asked to do is in section 1.5 is to look at increasing, decreasing, or constant. So they want to know in this graph that we have here, how do I know where it's increasing and where it's decreasing? Okay, so for one thing, let me just go ahead and draw some arrows here. So this is going forever. Okay. So the way I like to tell my students is to think of this, you want to go from left to right. And you're only looking at the x values, okay? Don't worry about the y values for this type of problem. So when it's asking for increasing, decreasing, constant, always look at your x values. So if we look at this problem, if we're walking from left to right, like if we're going from left to right, then we can see that the graph is decreasing, okay? And so I kind of put it here. So we're going left to right, the graph is decreasing. And then when it gets to this point, the graph starts to increase, okay? So where is it decreasing? Well, it's decreasing from -infinity all the way to you get to 6. Notice the 6, that's when it turns, right? So our interval is going to be from -infinity all the way to 6. Once you get to 6, then the graph starts to increase. And so I'm going to draw it here. It starts to increase. But again, what we're looking at is the x values. So from 6 to infinity, the graph is going to be increasing. Okay, so how do we write that in interval notation? So it's increasing from 6 to infinity. It's decreasing from -infinity all the way to 6. And then it's not constant in any part of this graph, so we put does not exist. Okay, let's try another one. So again, let me put some arrows here. So let me put some arrows. Okay, so if we look at this graph, we want to see what's happening with the graph. And so remember, you're going from left to right. And so from left to right, the first thing that's happening here is that the graph is decreasing. But at what interval is it decreasing? And then from this side, the graph is increasing. Okay. So let's look at the interval a little bit closer. So from 5, here's 5, to infinity, the graph is going to increase. And then it's decreasing from negative infinity, all these values here, all the way until it gets to negative 5. Now, anytime you're working with increasing and decreasing and constant, you're always going to use parentheses because we're looking at an interval, okay? So you don't use brackets. You only use brackets whenever you're dealing with domain, okay? So that was just some quick examples on increasing, decreasing. Now we're going to go ahead and jump to combination of functions. So you're going to see these in section 1.8. And so here we go with these combinations. So basically what happens here is they give you two functions and we're going to combine them using operations. So we're going to use addition, subtraction, multiplication, and division. So whenever they ask us to find f plus g of x, the first thing that I like to do is I like to rewrite this the way it's defined. So I can rewrite this as f of x plus g of x. And that just makes it easier for me to see what I need to do. So here, f of x, they tell me is 3x minus 7. And g of x, they tell me is 4 minus x. So I'm going to substitute those values in there. So my f of x is 3x minus 7. My g of x is 4 minus x. Okay. And now we just simplify. So 3x minus x is 2x. Negative 7 plus 4 is negative 3. So this would be your answer. Now for subtraction, same idea. We rewrite it. So this is f of x minus g of x. I'm going to substitute my values. So f of x is 3x minus 7 minus, and notice I put parentheses here. The parentheses is important because that minus sign has to be distributed all the way across. If you forget the parentheses, then one of the common mistakes is that the negative is only applied to the first number. So if we simplify, now we have 3x minus 7. Negative times 4 is negative 4. And then my negative and negative is positive x. Combined like terms, 3x plus x is 4x. Negative 7 minus 4 is negative 11. And now let's do the multiplication. So here we have 3x minus 7 times 4 minus x. So we're just going to multiply everything. So 3x times 4 is 12x. 3x times negative x is negative 3x squared. Negative 7 times 4 is negative 28. Negative 7 times negative x, positive 7x. Combine your like terms. So we have negative 3x squared plus 19x minus 28. Okay, so next we're going to do division. F divided by g of x. And so the same thing, we want to rewrite it so that it's written the way we defined. So f of x divided by g of x. And then substitute our values. So we have 3x minus 7 divided by 4 minus x. And so here we cannot simplify any further. So this would be our answer. So now we want to know what is the domain of f divided by g. So last week we talked about domain and we said, well, if you have a fraction and you have a variable in the denominator, then that means that there's some restrictions. There's some numbers that cannot be part of the domain, and those numbers are whatever causes you to get a 0 in your denominator. So for some of us, we could see what that number is, but if you're not sure, it's okay. We just take the denominator, 4 minus x, set it equal to 0, and solve for x. So here we get, subtract the 4, and then divide by negative, so we get 4 is equal to x. Or bring the x to the right side, and we get 4 is equal to x. So what this means is that the domain is all real numbers except for 4. Because if we put 4 in here, we get 4 minus 4 is 0, and we cannot divide by 0. So in interval notation, we can write it as all the negative numbers all the way till you get to 4. So here should be a comma. And then we use our union symbol, and then from 4 to infinity. Okay, so let's try another one here. So again, we're adding these together, so I'm going to rewrite them. I'm going to substitute f of x, which is x squared, and g of x is 2x minus 5. Then you want to combine any like terms. There's no like terms here, so that would be our answer. Now for subtraction, we're going to rewrite it, substitute our values. So f of x is x squared minus g of x, which is 2x minus 5. We're going to distribute that negative into the parentheses. So negative times 2x is negative 2x. Negative times negative is positive 5. And there's nothing that I can combine anymore, so that's my answer. And then for multiplication, we're going to multiply these out. So x squared times 2x and x squared times negative 5. So we get 2x cubed minus 5x squared. So that's going to be our answer. And then the last one, division. If we rewrite it, we get x squared divided by 2x minus 5. I cannot simplify further, so that's going to be my answer. And then they want us to find the domain. So to find the domain, we take the denominator, 2x minus 5, set it equal to 0, solve for x, so add 5 on both sides, divide by 2. So the domain is going to be all real numbers except for 5 halves. So the way we write it is from negative infinity to positive 5 halves union 5 halves to infinity. Okay, so here's one with the square root. So we have f of x is equal to x squared plus 3, and g of x is the square root of 2 minus x. And so if we continue, we have f of x plus g of x. So we're going to have x squared plus 3 plus the square root of 2 minus x. And then if you have like terms, then we're going to combine them. But in this example, there isn't any like terms, so our answer is just x squared plus the square root of 2 minus x plus 3. And then if we subtract, we have f of x is x squared plus 3 minus the square root of 2 minus x. And so if we distribute the negative, then we're just left with x squared plus 3 minus the square root of 2 minus x. And you can rewrite it, or that can be your answer. Okay, so now for multiplication, we have f of x times g of x. So f of x is x squared plus 3 times g of x, which is square root of 2 minus x. And so if we multiply, then we're going to end up with, so here I didn't multiply them. The system would take this answer, but if you wanted to rewrite it, it would be x squared outside and then square root of 2 minus x. Let me just write it out. Hold on. Let me get my pen. So you could rewrite it as x squared square root of 2 minus x plus 3 times 2 minus x. Okay. And then the last one is the division. So we have x squared plus 3 divided by square root of 2 minus x. So here we cannot simplify, but we want to find the domain. So to find the domain, notice we have a fraction. So there's going to be some numbers that we cannot use, but we also have a square root. So now we have to worry about not having negative numbers. So for the square root, we take the radicand, which is the inside of the square root. So that's 2 minus x. Set it greater than or equal to 0 and solve for x. So here I'm going to add x on both sides. So I get x is greater than or equal to 2 is greater than or equal to x, or if I rewrite it, it's x is less than or equal to 2. Okay, so your domain is any number that is less than or equal to 2. But now we have to worry about the 0. So we can take your denominator, square root of 2 minus x, set it equal to 0. So in order to solve for x, I'm going to square both sides. The square root and the 2 will become a 1, or they cancel out. So we get 2 minus x is equal to 0. So we get x is equal to 2. So your domain cannot use the number 2, and it has to be all numbers less than or equal to 2. So to write it, we would say negative infinity all the way to 2, but I'm going to use a parentheses because I don't want to include the 2. Okay, now the next part of this section is something called composite functions. So composite functions are functions that look like this. So the symbol that you're going to see is an open circle. Don't confuse it with multiplication. So if you see this little open circle here, that means that you're working with a composition. Okay, so they still give you two functions. And so let's go ahead and try the first one. So if you have f composed of g, one, you can rewrite it so that it looks like f parentheses g of x. The first function that you see will be on the outside, and then anything else will be on the inside. Okay. So what you want to do here is evaluate the function. So we know what g of x is, right? G of x is x minus 3. So we're just going to substitute that in here. So my first step is going to be f of x minus 3. Now my second step is to evaluate the function f at x minus 3. So what that means is you're going to take whatever is in the parentheses. So you're going to take all of this, and we're going to substitute it into the x for the function g. Okay, so let's go ahead and do that. So here I have an x, and wherever I see an x, I want to replace it with x minus 3. So that's what I wrote here, x minus 3. Then I have a plus 4, plus 4. Now we simplify, so we get that the composition is equal to x plus 1. Okay, let's try g composed with f. So now notice that g is listed first, so g will be on the outside, followed by f of x in the inside. So we're going to replace f of x with x plus 4. And now we're going to take whatever is inside of g, which is x plus 4, and we're going to go find the function g. And wherever we see an x, we're going to substitute it into the x plus 4 into the x. So here we have x, so we're going to have x plus 4 minus 3. Simplify, we get x plus 1. Now notice that we got the same answer, right? We got x plus 1 and x plus 1. So that is just a coincidence. It doesn't happen all the time. Okay. So now the last one is g composed of g. So whenever you have the same function, it's okay. We still rewrite it. So the first function is g. The second function is g. So that's going to be on the inside. We're going to replace g of x with x minus 3. So here's x minus 3. And now whatever we have inside of the function g, we're going to replace it. We're going to go to the function g. Wherever you see an x, we're going to replace it with x minus 3. So we get x minus 3 minus 3. So if we simplify, we end up with x minus 6 for the composition g composed with g. Let's try this one. Find f of g, g of f, and g of g. So here we have f composed of g, so we get f of g of x. So g of x is x minus 2, so we're going to substitute it. And now we're going to take x minus 2, go to the function f, and wherever I see an x, I'm going to replace it with x minus 2. So we get x minus 2 squared. We're going to simplify, so I can write x minus 2 squared as x minus 2 times x minus 2. So if we multiply, we get x times x is x squared, x times negative 2 is negative 2x, negative 2 times x is negative 2x, negative negative is positive 4. So we get x squared minus 4x plus 4. Now we do g of f. So again, the first function is on the outside, and then the second one is on the inside. So f of x is x squared, so I'm going to replace that. And then I'm going to substitute x squared into the function g. So here I have an x, so I'm going to replace it with x squared. So we get x squared minus 2, and then that would be our answer. Then the last one is g composed of g of x. So if we substitute it in there, we get g of x minus 2. I'm going to take this information, plug it in for x. So I get x minus 2 minus 2, which is x minus 4. Okay, so that is the composition. If you have any questions, please let me know. And so we're going to go to the next one. This one has a square root. Okay, so we have f of x is the square root of x plus 4. G of x is x squared. So f composed of g can be written as f of g of x. So my g of x is x squared, so I'm going to replace it. And now I want to take x squared and I'm going to plug it in for x. Okay. So if I do that, let me just circle it so we can see it. So what I did is I took x squared and we're going to put it in for f. Okay. So we get the square root of x squared plus 4. And I can't simplify any further, so that's going to be my answer. And then g of f, we're going to do the same. F of x here is the square root of x plus 4, so I'm going to replace that. And now I have g of the square root of x plus 4. So I'm going to take whatever is in here, and I'm going to go to the function g and place it into the x. So now we have the square root of x plus 4 raised to the power of 2. So a lot of times when you see this, then we like to say that the square root and the 2 cancel, but they don't really cancel, they become 1 because the square root can be written as a half, and then you have this raised to the second power, and then this is going to be 2 over 2, which is going to be a 1. Okay, but if it helps you to say that they cancel, then that's okay too. So my answer here is just going to be x plus 4. Okay, so then the next one is wanting us to find a domain. So here, the domain, they want us to find the domain of, let me just make sure that we get the right domain. So it says find the domain of each function and each composition. Okay, so we're going to find the domain for A and B. So let me keep going. Okay, so for the domain, it's a little bit different than just working with a regular function. Okay, when you're dealing with compositions, you have to consider a second step. So one of the things you can do first is just find the domain of each of these functions. So the domain of f is going to be, you have a square root, so we can set the radicand x plus 4 greater than or equal to 0. So if we solve for x, we get x is greater than or equal to negative 4. So the domain goes from negative 4 to infinity. Just for the domain, just for the function f, just for this one here. Now for g, we have x squared, so there's no fractions, there's no square roots, there's no logarithms. Therefore, the domain is from negative infinity to positive infinity. And then now we're ready to find the domain of f of g. Well, if you look at f of g, we have square root of x squared plus 4. So all you really, what you might be thinking is, well, don't I just find the domain of the square root of x squared plus 4? And the answer is no. For compositions, we have to take another step, okay? So the first step is you can find the domain of your composition, which is the answer. And so here we have x squared plus 4. X squared plus 4 is greater than or equal to 0. So if we subtract 4, we get x squared is greater than or equal to 0. So no matter what x is, even if it's a negative, it's always going to be greater than or equal to 0. You can have a negative here, it's going to become positive. So the domain for x squared plus 4, the square root of x squared plus 4, is just negative infinity to positive infinity. Then you want to find the domain of the second function, which is the inside function. So in letter A, that inside function is g, okay? So we're going to find the domain of g. Well, we already did that. It was negative infinity to positive infinity. Now your domain of the whole composition is going to be what's common to step 1 and step 2. So in step 1, we had negative infinity to positive infinity. Step 2, we had negative infinity to positive infinity. So what do they have in common? They have in common everything. So your answer is just negative infinity to positive infinity. So here it didn't make much of a difference, but you'll see on the next example why it's important to follow these 3 steps. Okay, so let's try the next example. So it's kind of crowded in here, but let's focus on the right side over here. So it says the domain of g of f. So remember, the domain of g of f, the answer for that was, let me circle it since there's a lot of stuff on here. If you look at this circle, what I circled here in red, if I asked you to find the domain of just this in red, then we can see that there's no fractions, there's no square roots. This is a line, so the domain is just going to be negative infinity to positive infinity. What happens is if you enter that as your answer, it's going to be wrong, and this is going to be the reason. Okay, so step 2 is consider the inside function. Remember, your inside function is, let me circle it here, it's going to be that second function. So you want to look at the domain of this second function. So if I write it in here, we get the square root of x plus 4. The domain only goes from negative 4 to positive infinity. Okay, now step 3 is, what does step 1 and step 2 have in common? Well, the only thing they have in common is from negative 4 to infinity. So the answer, the domain for this composition is negative 4 to infinity. Okay, so you might be asking yourself, why is it that this, why is this the reason, or why does it come out this way? Well, let's say that you were looking at evaluating, let me give you an example. Let's say I asked you to find f, hold on, g composed of f of negative 5. Then that's going to be g composed of f of negative 5, right? So now when you're ready to enter this information into the function f, then notice what happens. We get the square root of negative 5 plus 4, which is the square root of negative 1. And we cannot take the square root of that negative number without using imaginary solutions. That's why it's important to always look at that second function and consider it so that we can find the true domain of the composition. Okay. All right, let's try one more just to make sure. So f composed of g, we can write as f of g of x, and then g of x is x plus 2. So I'm going to substitute that in for x, so we get 1 divided by x plus 2. G of g composed of f, we get g of f of x. F of x is 1 over x. I'm going to substitute that in for x, so we get, for this x, I'm going to write 1 over x plus 2. And so that's my composition. And then it says to find the domain of, I'm assuming it said find the domain of everything, right? So first we find the domain of f. So here x cannot be 0, so it's going to be negative infinity to 0, and then 0 to infinity. Okay. And then the domain of g is a line, so this is negative infinity to positive infinity. And then we're going to do the composition. So the domain of this composition here, x plus 2, x cannot be negative 2, so the domain is negative infinity to negative 2, union negative 2 to infinity. Now we consider the domain of g. Why g? Because g is your second function. Well, the domain of g is x plus 2. The domain will be all real numbers, negative infinity to positive infinity. So what does step 2 and step 1 have in common? It's going to be negative infinity to negative 2, union negative 2 to positive infinity. Okay. What about the next one? So here, the domain of g of f. So if we consider the domain here, x cannot be 0, so we go from negative infinity to 0, union 0 to infinity. The domain of f, why f? Because that's a second function. It cannot be negative infinity to 0, and then again 0 to infinity. So what do they have in common? Negative infinity to 0, union 0 to infinity. Okay. Now one of the questions they're going to ask you is, find two functions f and g such that f of g of x is equal to h of x. So what they're doing here is they're already giving you, let me go back one, they're giving you the answer. They're giving you this answer, and they want you to find what f of x is and what g of x is. Okay, so that's what they're trying to make us do. So one, you could try, usually what you want to do is you can pick, you can call it f of x or g of x, or vice versa, it doesn't matter. So here it says f of x, what is in the parentheses? Okay, so in this example, if we look at the parentheses, we have 3x plus 9. And then g of x is the outside of the parentheses. In other words, you have this square. Okay, so we consider that f of x is inside, which is 3x plus 9. G of x is whatever is outside. So here is going to be my square. Okay, so it's going to be x squared. And now what you want to do is you just want to check. So if I wrote g of f is equal to 3x plus 9 squared, let's see if that works. So let me write it out. Give me a second. So if we have g composed with f, then this is g of f of x. And so if we write it out, f of x is 3x plus 9. And so now if I plug it in, then we're going to take this in for x. So we get 3x plus 9 squared. Is this what they wanted us to have? Yes, right? Now the only thing here is that the problem wants you to use f composed of g. So they actually want it to be the other way around. they want it to be f composed of g. Okay, so we're gonna need to switch them. Okay, so instead of g of x being x squared, you can call this f of x, and this one can be g of x. Okay, so let's try another one. I think I have another one here. So here we have h of x is square root of 2 minus x. What is in the inside? What is in the square root? And then g of x would be the actual square root. So f of x, we can call it 2 minus x, that's the inside. And then the square root of x is the outside. Okay. And then we're going to have the same idea. So if we try g of f, then that will give us the answer. So we'll probably need to switch them again. Okay, because if you do f composed of g, then notice what happens. You have f of g of x, which is square root of x. And then we're going to end up with 2 minus square root of x. And this one does not look like this one, right? So let's switch them. This would be your g of x, and then this is your f of x. So that if I do it now, notice what happens. F of g of x. So we get f of g of x. And then if I plug it in, then we get the square root of 2 minus x. Okay? So when you're doing these, it's still always the same. Whatever's inside is one of the functions. The outside is the other one. But then you need to figure out which one is g of x, which one is f of x. Okay. So last week, I didn't have time to cover the difference quotient. And this one is from one of the previous sections. Since we have a little bit of time, I can cover an example. I added them here just in case we ran out of time, then you would at least have it with you. So if you want to download this PowerPoint, probably around this area where I have the blue check mark, there, if you look at up above that blue check mark, there's another box with an arrow pointing down. So if you click on that, it will let you have this PowerPoint. Okay. So I'll do one difference quotient, and then we'll it will probably run out of time by then. So the difference quotient is something that, for those of you that need to take calculus, you'll have to use in that class. But it looks like this. So f of x plus h minus f of x divided by h, where h does not equal 0. Okay. So if they ask you to evaluate a difference quotient for f of x equals 3x plus 1, you kind of want to do this in parts at first. Okay, so the first part is f of x plus h. The second part is f of x. And then the third part is we're going to subtract them and divide by h. So the first part, we have f of x is equal to 3x plus 1. And so if we substitute x plus h for x, then we're going to have 3 times. So anywhere you see an x, you're going to substitute x plus h. So then we're going to have 3 times x plus h plus 1. So we end up with 3x plus 3h plus 1. And then the second part, f of x, is just going to be itself, 3x plus 1. Now we subtract them. Then let's subtract them here. So we have 3x plus 3h plus 1 minus 3x plus 1 divided by h. I'm going to distribute that negative, so we get negative 3x minus 1. And if you're doing this correct, you should have some values that cancel out. So 3x minus 3x is 0, 1 minus 1 is 0, and we're left with 3h divided by h. So the h are going to become 1. So the difference quotient for f of x equals 3x plus 1 is going to be 3. Okay, we can try another one here. So again, you have x squared minus 4x plus 7. So first, you're going to go ahead and replace the x squared with, or the x with x plus h. And we get x plus h squared minus 4 times x plus h plus 7. Then we're going to multiply these out. So x times x is x squared. X times h is xh. H times x is hx. And then h times h is h squared. Distribute the negative 4. So negative 4x minus 4h. And then you have your plus 7. Gather any like terms that you might have. So I have xh is 2xh. And that's going to be what I have for the first part. The second part is just itself, x squared minus 4x plus 7. And now we're going to subtract them. So we have x squared minus 2xh plus h squared minus 4x minus 4h plus 7 minus all of this. So we're going to distribute that negative. So negative x squared is negative. Negative negative is positive 4x minus 7. Cancel out any like terms. So those terms cancel. And what we cancel out any like terms. So those terms cancel. And what we have left is negative 2xh plus h squared minus 4h divided by h. Notice that in the top, these three terms have h in common. So you can factor out an h. And then you're going to have cancel out the h's here. So we end up with negative 2x plus h minus 4. And that was it. So if you have any questions, you're welcome to stay here and ask any questions. And I'm going to pass it over so they can tell us what we're looking at for next week.
Thank you so much, Ms. Chuka. So again, if you guys would like to download a copy of the presentation, you guys can go to the top right corner and click on the little box with an arrow pointing down. That'll download the presentation or whatever's on the screen. So we do want to remind you guys about our previously recorded sessions, which are available on a YouTube playlist. This session will also be available in that playlist later today. Also linked was a short survey to help us improve our TVE sessions. Please take a few minutes to fill out that survey, and before you all leave, I want to share the TV sessions that we'll have next. So at 1 p.m. today, we'll have a presentation with the EPCC Mental Health Committee with Christian Salas, and we will be back with Happy Math Hour next week at 11 a.m., where Math 1314 will cover inverse functions in Exam 1 review, and Math 1324 will cover the Exam 3 review. Our 1 p.m. session next week will be a presentation with the Multimedia Studio with Fernando Calel Mares. Thank you all for coming in today. We hope you all have a lovely weekend. If you have any